Today we're talking about eddy currents, which is little tiny circles of electricity, basically electrons moving around in circles when metals move by magnets, or when magnets move by metals, either way. It's a special little interaction of magnetism, and it's pretty cool because it takes energy to cause anything to move. And so if I drop this piece of aluminum through a magnet, and then there's little tiny whirls of electricity in there, it has to get the energy from someplace. Well, let's just see what happens. If I take a regular piece of cardboard and drop it through the magnet, it falls like normal. Why? Well, that's because cardboard doesn't conduct electricity. So when it passes through the magnet here by the strongest magnetic field here, there's no eddy currents. The electrons don't whiz around, so it doesn't cost any energy for it to pass through. All right? But when I go with aluminum, it falls very slowly because aluminum conducts electricity. So the energy that would normally accelerate the aluminum down and make it drop real fast is instead taken up by spinning electrons around in circles there, right, which will absorb the energy. It's called eddy currents. You can see that more visibly if I take something like this, piece of aluminum with some strips in it, cut out, so there's not as much eddy currents going on in there. They're very small, I mean, so they still go on, but you'll watch it fall slowly at first, but then fast whenever it goes past the striped regions, like so. We can try a piece of steel and watch it fall, and it does actually fall a tad bit slower, but not that much slower, because it doesn't display as strong of eddy currents in it. Here's a piece of lead, which again is metal, and you can see that it does fall a little slower than you expect it to if I was just dropping it flat, but it doesn't quite fall as slowly as the aluminum. Let's look at another couple cases. Okay. So I've got a long copper tube, and it's got open parts, and it's got solid tubing. Copper is a conductor, so it's going to have these eddy currents appear in them. And then I have these two projectiles. All right? And one is going to have no magnet in it, and so when I drop it, it's going to fall straight on down to the floor. And this one has a magnet in it, so when I put it in the tube, as it moves by the copper, it's going to create little eddy currents, and it will go slower as you fall down. So we have an example of the bullet without any magnet in it, and it falls right through. And then we have another example of the bullet with a magnet in it, and it falls slowly, 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 goes fast, and then falls slowly again. And it's speeding up because that hole in the tube has less copper, so fewer eddy currents. I've got a piece of special green paper, and this paper will display a magnetic field behind it. So when I move a magnet behind it, you can almost see the magnet moving back there. So when I wrap this around the copper tube, I can prove to you that it's falling fast up here, slow inside here, sorry, and faster when it falls to the bottom. Here we go. There it went. There it went. There it went. Grand finale. It's nothing new. It's, again, eddy currents and slowing down of things that conduct as they pass through a magnet. But it looks impressive. Come on. What I've got is two giant coils of wire. These are going to create really strong electromagnets in here. I have an aluminum disc on a nice pendulum, and it's just going to pivot like that, back and forth. Pendulums just keep going back and forth like that. They don't stop. However, when I send electricity through these coils, I make huge, big old electromagnets, and then we'll have a magnetic field there. What's going to happen to aluminum? It should stop. So here goes. Let's try it out. We got a rocking just nice. Send in electricity. Boom, it stops. Just like that. Let's watch it again. Turn on electricity. Boom, and it stops. So we learned today that particles, metals that conduct electricity, when they pass by a magnetic field, will have currents of electricity induced in them, and that will take energy. So it takes energy to push them past the magnetic field. So the cool thing you can do then is all kinds of cool stuff. You could use this, if this were an amusement park ride and you were going along really fast, you could just turn on the brakes and bring everybody to a nice smooth halt. So until next time, enjoy magnetic braking.